Okay, so chapter 13, carbonates. So first of all, you can see our example, calcium carbonate. This is famous because you can get calcium carbonate from the cave. So we call that limestone in general. So you can see the structure or the chemical structures of calcium carbonate. Calcium and then carbonate is carbon with 3 oxygen. So over here they show us a cycle where if you heat up calcium carbonate, then carbon dioxide is released as gas, and then calcium oxide is obtained. We call calcium oxide the quicklime. Okay, so quicklime. So after that, you heat it again. Then at the meantime, oh, this is not heating. This is adding water. Quicklime, add water to it. The heat is pointing outwards, meaning that it is releasing heat to the surrounding. Okay, so you add water to to quicklime, then what you get is slaked lime. Okay, slaked lime. So of course, to remember the name, right, you may think of it in this way: limestone, you heat it, then you will quickly get quicklime. So something that you can get immediately, quicklime. So if you add water to it, then it becomes something like sticky. It's a sticky stuff, so like gum, something like that. So it's slaked lime. The name seems like help us to remember. So slaked lime, okay, is calcium hydroxide. You add water to it, heat is released, then calcium hydroxide is obtained. So it looks like gum, looks like the dough when you make bread. And after that, that is where you add a bit of water. So if you add more water, the stick lime dissolve and they form aqueous calcium hydroxide, which is lime water. So if you look at the chemical structures, it remain the same. It's just calcium hydroxide. The difference is this is a little bit of water added. It looks sticky like dough when you make the bread, like gum, very sticky, but this is solution, lime water. Okay, so we know that lime water is to test the presence of calcium, the presence of carbon dioxide. So carbon dioxide will make lime water turns cloudy or turns milky. That is the fact that we normally heard. So what happened here is when you add carbon dioxide into lime water, so the observation is where it turns cloudy and milky, and that is actually the formations of calcium carbonate. Okay, now let's look at the cycle over here. We have limestone calcium carbonate. So you heat it, carbon dioxide is released, then you get quicklime, which is calcium oxide. Then you add water to it, add a little bit of water to it, it becomes slaked lime. Slaked lime is sticky, it's calcium hydroxide. Then you add more water, it becomes lime water. So once it becomes lime water, then you can add carbon dioxide to it. It turns cloudy. That is the reformations of calcium carbonate. Okay, now we see the point here. Lime is manufactured by limestone by heating. Okay, so you heat the limestone, then you get quicklime, right? So quicklime is also lime. Okay, it's also lime. So calcium carbonate you heat, then you get calcium oxide, which is lime and carbon dioxide. Second point, uses of quicklime. So that means the usage of calcium oxide. Making steel from iron, use calcium oxide to make steel. Okay, so let's take a look. Calcium oxide is used in metallurgy industry with different purposes. In steel, is incorporated during iron and steel process as clinker agent for then be able to eliminate impurity existing in metal parts. Calcium oxide must contain of a high purity to improve its reactivity and performance. So they give some explanation, but in detail, how is it? No need to care that much. Okay, no need to care that much. So they give a little bit of information here. So let's see. Calcium oxide must contain of a high purity to improve its reactivity and performance. So that means calcium oxide itself must be pure calcium oxide so that they have good reactivity and good performance. So then seems like they don't tell clearly what is the usage of calcium oxide. Calcium oxide is used in metallurgy industry with different purposes. In steel, is incorporated. This one is not that clear. Okay, let's see the other one. Calcium oxide. Okay. There are several reactions in the iron and steel making processes which involve acid and bases. One of the raw material which is fed into the blast furnace is limestone, an almost pure form of calcium carbonate. Limestone decomposes in the hot furnace to give calcium oxide, which is a base. So this is better. So that tell us calcium oxide act as a base here. Okay, act as a base. Calcium oxide joins with acidic impurity in the ore. So you see that tell us clearly the functions of calcium oxide is to neutralize the acidic impurities in the ore to make a salt. Calcium oxide plus silica become calcium silicate. So the biggest impurity is silica, a weak acid, which combine with calcium oxides to make calcium silicate, a salt which is formed as a molten slag. So this is slag. Calcium oxide also play an important part in the basic oxygen steel making furnace. Here it helps to remove impurities such as phosphorus and sulfur from the steel. So you see its role is to react with the impurities. Okay, so phosphorus is a non-metal and produces an acidic oxide, P2O5. In the BOS furnace, P2O5 combined with the basic calcium oxides to make calcium phosphate. This forms part of the molten slag which collects on the surface of the molten metal. So we get the idea already. The usage of calcium oxide in steel making is to react with the impurities, acidic impurity especially. So which means calcium oxide act as base. Okay, so that's the thing. Maybe I just screenshot this and put at the side so that you can always able to refer back. Okay, so this one, the explanation on the usage of calcium oxide in steel making. They are not part of the compositions of steel, but it is like assisting in steel making. So taking a role of
the calcium, the quick lime, right, has to clean impurities.
Yes, to remove impurities.
So what are the impurities actually? It's like ore and stuff like that.
You know, you get the iron ore from the earth, so that you have sand that stick to it. So the sand is silica. So the sand that stick to the iron ore is silica. So you use calcium oxide to remove the silica. That means general idea is like removing the sand, you know. It's that idea.
Calcium oxide is quicklime.
Quicklime, yes.
Okay, sir.
So we use the quicklime to remove the silica.
And then the quicklime is like a glue texture. It's in glue texture.
Glue textures is actually slate lime.
Oh, okay.
Yeah, slate lime is the one in glue textures, like glue. Okay, so yeah, after adding a bit of water, so it's like sticky properties. It has sticky properties.
Can I know, sir, what's the texture of quicklime?
Quicklime, if you want to see, it's just like a white solid on it. So you see, okay, quicklime. Okay, so you can see here, just like a white solid stone and a powdery form.
Okay,
So
sir.
it looks like that. Compared to slick lime, you see here, slick lime. Slick lime, you know, you add a bit of water to it. So something like this. Okay. Slick lime, or maybe this one, you see like sticky, like have some water, you know, like flour added with water already, you know, that kind of idea. So maybe this one, yeah. Okay, so that's the thing. Now let's move on. So if you understand the process just now where the calcium oxide is to react with silica, then this point should make sense as well, because to neutralize acidity in soil. So the soil has acid, for example silica. So the calcium oxide, which is a base, will neutralize the acid. Then after that, we have the drying agent in industry. Drying agent in industry is where, you know, quicklime tend to absorb water to form calcium hydroxide. So if you have this idea, then drying agent should make sense. So where, imagine that they absorb water, then they dry out whatever you plan to dry out. So it works in that way. Okay, now let's continue. Uses of, yes.
I'm so sorry. You said that when quicklime reacted with water, it becomes something sticky called slake lime.
Yes.
Okay, sir. You can continue, sir.
Okay, so it helps us to remember the third usage, drying agent. You know, they tend to absorb water to become stick lime, so they tend to absorb water from others, so they act as drying agent. Okay, so interrelated. Now we look at the next point here, uses of slake lime and lime. So uses of slake lime and lime. So you know slake lime means calcium hydroxide. The lime that they mean is actually calcium oxide. As they mentioned here, lime is manufactured by limestone by heating. So this is also lime. Lime. Okay, so now let's see. Neutralize acidity in soil and in lakes affected by acid rain. So you know, the calcium oxide, calcium hydroxide, they are bases. So they act as base which neutralize acid. neutralizing acidic industrial waste products, example, flue gas, desulfurization. Okay, so let's take a quick look on what it means by flue gas desulfurization. So we just need to know a little bit on this. Okay, so let's look at the internet. Flue gas desulfurization. Okay, so this one. Flue gas desulfurization is a set of technologies used to remove sulfur dioxide, SO2, from exhaust flue gases of fossil fuel power plants. And so imagine the combustions of fossil fuel produce sulfur dioxide. So we want to remove sulfur dioxide from the exhaust. So, and from the emissions of other sulfur oxide emitting processes, such as waste incinerations. Okay, so methods, no need to know in details. So you just need to know at this point, flue gas desulfurization is to remove sulfur dioxide. And we know the lime and the slaked lime are base, they are bases. So the base, logically, it can react with sulfur dioxide because we know this is acidic. So this is acidic. So neutralize it. So neutralize the sulfur dioxide. So then it will avoid acid rains because of this SO2. So we get the idea by looking at that. So flue gas desulfurization, conclusions is where SO2 reacts with lime or slaked lime. Okay, so SO2 is a pollutant, acidic pollutant. So that's why here neutralizing is used. Neutralizing, so the base is neutralizing the acidic SO2. Uses of limestone, making cement. Made by mixing limestone with clay, heating mixtures strongly in a kiln, adding gypsums like calcium sulfate, and grinding up the final solid to give a powder. Okay, so just roughly okay, no need to know too much on that. Okay, making iron from iron ore. Limestone react with sand, forming slag, calcium silicate. So this one is the one that we discussed just now. Okay, the one that we searched for it. The limestones will change into quicklime first. The quicklime will react with the silica to form calcium silicate, which is then used for road building. So you get the slag, we use the slag for road building. Okay, so properties of carbonate. Most metal carbonates thermally decompose when heated to form the metal oxides and carbon dioxide gas. For example, so you can see here, copper 2 carbonate, you heat it, copper 2 oxide is obtained, then another product, carbon dioxide. The group 1 metal carbonates, except for lithium carbonate, do not dissociate on heating. It is generally found that the carbonates of the more reactive metals are much more difficult to dissociate than copper 2 carbonate. So if the metal here is group 1, they don't dissociate except lithium carbonate. So copper 2 carbonate, yes. Calcium carbonate, yes. They decompose to copper 2 oxide or calcium oxide. So, but group 1, no. Carbonates are generally insoluble in water except for those of sodium, potassium, and ammonium. So we call it SPA. SPA always dissolve in water. Okay, so other than SPA, the rest are insoluble in water. Like calcium carbonate, insoluble in water. So you want it to dissolve in water, you need to change it to quicklime. Then after that, you can make it dissolve in water. Okay, so calcium carbonate plus, calcium carbonates can react with acid because carbonate, right? So carbonate can react with acid, then they form salt, which is calcium chloride, plus carbon dioxide, plus water. Okay, so they form this. Then let's see, test for carbonate ions. Calcium carbonate plus HCl, calcium chloride, CO2, H2O. This is the equation just now. It is also used as a test for a carbonate because the reaction produces carbon dioxide, which causes effervescence, and if bubbled through lime water, turns it chalky white. Okay, so that means we have to channel the carbon dioxide into lime water, and it turns cloudy or chalky. So showing that carbon dioxide is released, and from there we know that the carbonate is present. Okay, so now let's see here, carbon dioxide. So A contains by volume. Okay, there's a blank here. A contains by volume of carbon dioxide produced by processes such as something and something. Okay, so we need to fill out the blank here. A contains what by volume of carbon dioxide? A contains 0.04% by volume of carbon dioxide produced by processes such as, okay, so you may say combustions and respirations. Aerobic respirations. Okay, so let's see the equation here. Glucose plus oxygen, then you get carbon dioxide plus water plus energy. So carbon dioxide is produced. Okay. Photosynthesis. Carbon dioxide is taken in by plants through their leaves and used together with water, taken in through their roots to synthesize sugars. So the sugars here is glucose. This is the process of photosynthesis, and it takes place only in sunlight and only in green leaf, as they contain chlorophyll, the green pigment, which catalyzes the process. So you can see photosynthesis is where carbon dioxide is used together with water through sunlight and through chlorophyll. Then they form the sugar, which is glucose plus oxygen. Okay. Now, greenhouse effect. Some energy from the sun is absorbed by the Earth and its atmosphere. The remainder is reflected back into space. The energy that is absorbed helps to heat up the Earth. The Earth radiates some heat energy back into space, but the greenhouse gases, including carbon dioxide, prevent it from escaping. This effect is similar to that observed in a greenhouse where sunlight, which is the visible and the ultraviolet radiations, enters through the glass panels, but heat has difficulty escaping through the glass. So it's this idea, the sun, the glass house, which trap heat, has difficulty escaping through the glass. Other gases also contribute to the greenhouse effect. One of these is methane, which is produced from agriculture and released from landfill sites as well as rice field. So methane is the gas from landfill sites. So which means the place where you put rubbish. So you can smell methane. The long-term effect of the higher temperature of the greenhouse effect and the subsequent global warming will be the continued gradual melting of ice caps and consequent flooding in low-lying areas of the Earth. There will also be further changes in the weather patterns, which will further affect agriculture worldwide. So the conclusion is, what is greenhouse effect? Is the trap of heat because of carbon dioxide. Okay. So of course it's not just carbon dioxide. Methane is another one which causes greenhouse effect, which means it traps heat. Okay, so let's move on. Okay, so we have done chapter 13. Okay, now let's see questions that involve carbonates. Okay, so we will start with question 1. So let's look at this. Question 1. Quicklime, which is calcium oxide, is made by heating limestone in a furnace. The reaction does not come to equilibrium. Suggest why the conversion of calcium oxide is complete. That means they change to calcium oxide, they don't go backwards, they don't come to equilibrium. Okay, so they cannot change back to calcium carbonate, basically because carbon dioxide is escapes or lost to the surrounding, go to the surrounding, escape to the surrounding. Okay, so because of that, they cannot combine with calcium oxide to reform calcium carbonate. So that is one of the possible reasons. So you may write it in that way. So where you said CO2 escapes. Calcium hydroxide, the slaked lime, is made from calcium oxide. Write an equation for these reactions. So you know you have to add water to calcium oxide. So calcium oxide plus water. Okay, then you get calcium hydroxide. Okay, so the equation is already balanced. Now C, calculate the maximum mass of calcium oxide, which could be made from 12.5 tons of calcium carbonate. 1 ton equal to 10 times 1 times 10 to the power of 6 gram. So you want to count the mass of calcium oxide, so we have to make use of this equation given there. Then first you have to change everything to mole first. The 12.5 ton is 12. Okay, let me show the working here. So mole of calcium carbonate is the mass, 12.5 times 10 to the power 6 gram, divided by the relative mass of calcium carbonate. So we have to look at the periodic table. So calcium 20, that's the atomic number. We take the 40, calcium 40, carbonate 12, oxygen 16. Okay, so let's count it. Back to the the one note. Okay, so calcium's carbonate 40 plus 12 plus 16 times 3. Okay, then after that we just use calculator to handle this. So I just count the bottom first. You get 100. 12.5 times 10 to the power of 6 divided by 100. So you will get still the big value, 125,000 mole. Okay, so that is the mole of calcium carbonate. Now the mole of calcium carbonate is also the mole of calcium oxide, because the ratio here is 1 to 1. So which is also the mole of calcium oxide. Now we want to find the mass of calcium oxide. So we just take the mole, multiply with the relative mass. We know calcium is 40, oxygen is 16. So then we just take that big value, multiply with 56. Then we will get 700,000 gram, which is 7 times 10 to the power of 6 gram, which is 7 ton. Okay, so 2 marks questions. Now let's see here, D. Limestone is used in agriculture to reduce the acidity of soil and for the desulfurization of flue gases in power stations. Most crops thrive in soils whose pH is close to 7. Calcium carbonate, which is insoluble in water, and calcium oxide, which is slightly soluble in water, are both used to reduce the acidity of soil. So there's 2 advantages of using calcium carbonates for this purpose. Okay, so calcium carbonate, you know, it is not soluble in water. That means it doesn't wash away by rainwater. So that is the advantage. It does not wash away by rainwater. This is one of the advantage. The other advantage why it doesn't dissolve in water is it does not increase the pH. It doesn't change the soil to an alkaline soil because it doesn't dissolve in water. So it does not increase pH above 7. Okay, so explain the chemistry of desulfurizations of flue gases. So that means the sulfur dioxide. Sulfur dioxide is reacted by the calcium oxide just now, the base. Okay, so first, flue gas. Flue gas contains sulfur dioxide. Then you said sulfur dioxide is acidic. Okay. Then we said calcium carbonate reacts. Calcium oxide is fine also. React with sulfur dioxide through neutralization. Give one other use of calcium carbonate. Okay, so it's the making steel, the one that we discussed just now, making steel or iron. In a blast furnace. Okay, so if you don't want this, I can give you one backup point, making cement. Okay, so that's the thing. Okay, so we assume settle for this.
Sir,
Yeah.
actually, I have some questions regarding the first question that you did.
Yeah. Okay, which one? Which part?
Actually, I don't understand 1A.
Sorry.
1A. I don't.
1A.
Yeah, I don't understand that.
Okay. 1A suggests why the conversions to calcium oxide is complete. It means when calcium carbonate heated up and it becomes calcium oxide plus carbon dioxide, the reaction doesn't move backwards to reform calcium carbonate. It means it has only forward reactions. It doesn't have backward reactions. That's why this sentence makes sense here. The reaction does not come to equilibrium. Equilibrium is achieved when the forward reaction and the backward reaction happens in the same rate. So for this situation, it doesn't happen because only forward reaction happens. Once the reaction happens in the forward direction, then it doesn't go backwards. So we have to tell why backward reaction cannot happen. The backward reaction cannot happen because carbon dioxide escapes. In order to make backward reaction happen, calcium oxide has to react with carbon dioxide. But the thing is, carbon dioxide is not around anymore. So that's why once they form the product cannot change back to reactants. That's why conversions, that's why they say once they form calcium oxide, then it's complete. backwards cannot happen because carbon dioxide escapes.
Okay, sir.
Yeah. Okay. Okay, so I just leave it like this.